Very good morning, all of you. In the last class, we have discussed the Bohr's atomic model. What are the important points? And next, expressions for the radius and orbit, derivation of Rydberg's constant, and formula for the velocity. So now we will see the merits and demerits. Merits and demerits of Bohr's atomic model. What are those merits and demerits of Bohr's atomic model? So, what are the first merits or advantages? So, it explains the atomic spectrum. It explains the atomic spectrum of hydrogen-like species. It explains the atomic spectrum of hydrogen, and hydrogen-like species means single electron, He plus 1 electron, lithium plus 2, 1 electron, beryllium plus 2, 1 electron. So it successfully explained the atomic spectrum of hydrogen-like species. And we see that it explained the stability of the atom. It explains the stability of the atom with respect to the stationary orbits. While electron is present in that particular orbit, it neither lose the energy nor gain the energy. So that is called as stationary orbits. So it explains the stability with respect to the stationary orbits. Next, the value of R, Rydberg's constant for hydrogen from Bohr's equation. The value what we are obtained 109677 centimeter universe. The value which we are obtained from the Bohr's atomic model that tallies with the value determined experimentally. Is it clear? What is the value we got in the Rydberg's constant in the Bohr's atomic model? The value is tallies which is determined experimentally. So these are the main important merits of Bohr's atomic model. So he explained the stability with respect to the stationary orbits, stability of the atom with respect to the stationary orbits, and he explained the atomic spectrum of hydrogen and hydrogen-like species, single electron containing species, helium plus, lithium plus 2, beryllium plus 3. Next, the value of Rydberg's constant is what we have got from the hydrogen from Bohr's equation. Tallies the value determined experimentally. Next, what are the demerits or drawbacks? It failed to explain the spectrum of multi-electron atoms. If any atom contains more than one electron, it could not explain the spectrum. Next, not explain the fine structure of atomic spectrum. If you observe the one line, high resolution spectrometer, each line splits into two more. Each line splits into two more. So why the splitting is occurring? If you observe that each line what we got in that atomic spectrum of hydrogen, each line splits into further few more lines. So why that fine spectrum we call that? Why this fine spectrum is occurring? What is the reason behind that? He could not explain that. It could not explain the G1 effect. What is the G1 effect? Splitting of very important G1 effect. Splitting of spectral lines in the presence of magnetic field is called Z1 effect. Z1 effect, splitting of spectral lines in the presence of magnetic field is called G1 effect. And splitting of spectral lines in the presence of electric field, that is called Stark effect. So, splitting of spectral lines in the presence of electric field is Stark effect. Splitting of spectral lines in the presence of magnetic field is G1 effect. These two effects are not explained by the Bohr's atomic model. Next, prediction of orbits. So, he predicted that around the nucleus we are having the circular paths. They are called as orbits. So, he predicted the orbits revolving electron. So in the particular orbits, electrons are revolving. It is against to the wave nature of electron. So what is the wave nature of electron? We will discuss next. So the revolving electron in the particular orbits, that prediction is against to the wave nature. Is it clear? So we will compare with the Bohr's atomic model. The wave nature is we try to overcome these drawbacks. Next, fail to explain the stability of the atoms to form molecules by chemical bonds. So formation of the chemical bonds that leads to the stability. So he could not explain the stability of the atoms with respect to the chemical bonds, but he explained with respect to the stationary orbits. Is it clear? So these are the merits and demerits or drawbacks of Bohr's atomic model.